Hey chemists, in this video we're going to be talking about percent composition of compounds. So let's say we have two compounds that contain potassium, K, chromium, Cr, oxygen, O. Here are their percentages of each element in the compound. If given these, which compound contains a larger percentage of potassium? I could look at the circle chart, the wheels here, and see it is the compound that has K2CrO4. But why? We're about to find out why the K2CR4 has a larger percentage of K compared to K2Cr2O7. And that's because something called percent composition. These are the percentages of each element in the compound. It's a relative amounts of elements in a compound. The percent composition consists of a percent by mass of each element in the compound. So let's try and find these percentages, this 26.8% Cr, 32.9% O, and this 40.3% K. So if ever given a chemical formula like K2CrO4, we can determine the percentages of each element using the molar mass of each element and then the molar mass of the compound. So let's look at K2CrO4. We're going to go like we're going to get the molar mass of this compound, but then eventually turn that into percentages. So K2CrO4, the mass of K in here, and look, I kind of like bolded the element that we're talking about and like made light the other elements in this compound. There's two Ks. So the mass of K is in this compound is 2 times 39.098 grams, which is 78.196. That's how much K is in this compound. Because as you can see, for every 1 mole of K2CrO4, there's 1 mole of K. Sorry, there's 2 moles of K. Oops, don't write that. There's 2 moles of K. You're going to see there's 1 mole of Cr. And we're going to see that there are 4 moles of O. So for the mass of Cr, it's just 1 times 51.996 grams, which is, of course, 51.996 grams. And these numbers, again, they're coming from the mass at the periodic table. And then finally, oxygen, you can see it's K2CrO4. There's 4 oxygen, so it would be 4 times 15.999 grams. And I get about 63.996. Now, of course, you could round these numbers to the nearest whole number. That's fine, too, for just approximations. But we're going to use all of the decimals. Now, if I want to get the molar mass, I need to add up all the masses of the elements in this compound. It would be the mass of K plus the mass of Cr plus the mass of O, which is 78.196 grams plus 51.996 grams plus 63.996 grams. And my molar mass becomes 194.188. grams per mole. So, what do I do with this to get percentages? Well, and you can kind of see it on the next page here. If I want to get the percentage of each element, I need the mass of that element in the compound, and I need to divide it by the molar mass and multiply by 100. So I'll do 78.196 grams of K divided by 194.188 grams of the compound K2CrO4, multiply by 100, and I get about 40.3% K. I could do the same thing for Cr. I'll get 51.996 grams of Cr divided by, again, that same molar mass, 194.188 grams of the K2CrO4, and I get times 100, and I get 26.8% of Cr. Now, there's 2 ways I could get the percentage of O. The sum of all percentages need to add up to 100. So I could do 40.3 plus 26.8, 40.3 plus 26.8, and I get 67.1. If I subtract 100 from 67.1, that's got to be the percentage of oxygen, which is 32.9%. But let's double check and do the math. If I want to get the percentage of oxygen, it's going to be this 63.996 grams that I got up here, divided by the molar mass, 194.18 grams, times 100, and guess what? I do get 32.9%. Let's see if these percentages match the ones in the wheel chart. Yes, they do. 26.8, 32.9, 40.3%. So that's how we get a percentage of each element in a compound, or what's known as a percent composition. I take the mass of the element, and it's typically the mass of that element in the compound, depending on how much there are. I divide it by the molar mass of the compound, and I multiply by 100. Let's quickly do another example with this. Let's say propane, C3H8. It's the fuel commonly used in gas grills, not Haz grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. What it's asking for is the percentage of carbon and the percentage of hydrogen. Well, I kind of already did a little cheating here, and I'm going to let you know that I know that the molar mass of C3H8, because I did the math, is 44. Let's do percentage of carbon. Well, in propane, C3H8, there are 3 carbons. So the percentage of carbon, I need 3 times the molar mass of carbon divided by the molar mass of this propane. So if I do that, 3 times 12, because that's the molar mass of carbon, that's 36, divided by 44, and now I got to multiply by 100 to get that percentage. 36 divided by 44, multiplied by 100, I get 81.8% carbon. Now, of course, I could do the math, and if I subtract 100, I should be able to get the percentage of hydrogen, which is 18.2%. But let's just do for fun, the math here. So for percentage hydrogen, there's 8 hydrogens in this compound. So let's do 8 times the molar mass of hydrogen divided by the molar mass of C3H8. That's going to get me towards my percentage of hydrogen. So 8 times 1 gram, that's the molar mass of hydrogen approximately. So that's 8 grams divided by 44 grams times 100. And I get 18.2%, like we got there. Boom, boom, boom. Okay? I'm going to leave example number 3 up to you. But again, I gave you a little help there that the molar mass of this acetic acid is 60. I'm going to let you know that there are 4 hydrogens in this compound, 2 carbons, and 2 oxygens. So use that information to help you with example 3 on your own. We could also simply calculate the percent composition if we're given mass data. So outside of molar mass, if I'm given mass data, I need to use the mass data. So let's look at this example. A compound is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. What is the percent composition? So what do we know? We know the mass of magnesium is 9.03 grams. We know the mass of nitrogen is 3.48 grams. We need the mass of the compound, the percentage of magnesium, or the percentage of nitrogen. Well, the mass of the compound is just the mass of Mg plus the mass of N. So if I do 9.03 plus 3.48, I get 12.51 grams. That's just these two add together to get the compound. It's just these two are combined to make your compound. Now, if I want to do percentage, same idea here, and I already kind of jumped ahead and wrote it. I need the mass of the element. I need not the molar mass now, I need the mass of the compound. If I divide those two and multiply by 100, I'll get my percentage of each element. So now this is a little bit easier because I already am given numbers. I don't have to do any extra calculations. I don't have to get a molar mass. So my percentage of magnesium will be my mass of my magnesium divided by my mass of my compound times 100. That'll be 9.03 grams divided by 12.51 grams times 100. If I do this math on a calculator, I get 72.2% magnesium. Now, I could subtract 100 from this and see that I'll get 27.8% nitrogen, because the sum of all percentages need to add up to 100. So 72.2 plus what number gives me 100%? That's 27.8. But let's do the math anyways. My percentage of nitrogen will be the mass of nitrogen divided by the mass of the compound times 100. So for us, that'll be 3.48 grams divided by 12.51 grams times 100. And look at that. If I plug that math onto a calculator, I will get 27.8%. And you could also check your work to make sure your percentages make sense. Make sure that the sum of the percentages add up to about 100. 99.9 or like 100.1 are also okay. That's just rounding errors. But make sure the sum of your percentages add up to 100 or you did something wrong. All right, I'll leave you with example number 5 on your own to try and check. It says 1 gram of hydrogen completely reacts with 127 grams of iodine, putting those numbers in, to form a compound, hydrogen iodide. I'm going to let you know 127 plus 1 is 128 grams. What is the percent composition of hydrogen and iodine? Using this information now, try and get the percentage of H and the percentage of I. And don't forget that the sum of those percentages needs to add up to 100%. All right, this is percent composition of compounds. You'll need this for our next big topic.